said, stop right there. I'm not into animal stuff.
Hi everyone,
You always give me the weirdest
welcome to this
shit.
session. I would like us to discuss mathematical concept. I will want us to discuss logarithm and indices. Okay, logarithm problems can be solved in two ways. Way one, we can solve logarithm problems by dropping the logs. Way two, we can solve logarithm problems by rewriting the problem in exponential form or in indices form. Before we can solve a few examples, I would like us to remind ourselves of a few properties of logarithm problems, or a few properties of logarithms. Property number one, log 1 to any base, the unknown, which is a. It can be 1, it can be 2, or any number. That one, log 1 to any base is always 0, and that is what we call zero exponent rule. Property number 2, we have log of the same base. Log a to base a will always be 1. That is the property number 2. Then we have log x base a plus log y base a. That one will give us log x y base a, and this is what we called it product rule. Property number 4, we have log x base a minus log y base a, which is equal to log x over y base a, and this is what we call quotient rule. Finally, we have property number 5, which is we have x log y base a. X is before the log, so this one can be as well written as log y power x base a, and this is what we call power rule. Before we can proceed, we can also remind ourselves of indices rule. When we have a number like this, x power a dot y power a, this can be as well written as this one. We can as well write it. No, I mean should be x power a dot x power b. This one can as well be written as x power a plus b. Similarly, when we have x power a over x power b, this one can as well be written as x power a minus b. And when we have 1 over x our A. This one we can as well write it as x power negative A. Those ones are indices rules, so we can solve a few examples. Examples which will help you to understand this concept keenly. Example 1. When we have a problem like this, these are a logarithmic equation. So as you can see, the bases of the log are similar. So the way in which you can use to solve this one is way 1, which is by dropping the logs. As you can see, the bases are similar, so we'll drop the logs. Then we will remain with 7x plus 3 is equal to 5x plus 9. Then we collect the log terms at this particular point. We'll have 7x minus 5x is equal to 9 minus 3. We have 2x is equal to 6. Divide both sides by 2. X is equal to 3. That is our answer. That is example 1. Example 2, we can have a number like this. Log x minus 2 to base 7 plus log x plus 3 to base 7 is equal to log 14 to base 7. For this case, as you can see, we have the same bases. So what we are going to do, as you can see, this other side, we have addition sign, and the bases are similar. So we can as well write it as log 7 and log to base 7, and the log itself is x minus 2. Now that we have addition here, it will now becomes multiplication. X plus 3 is equal to log 14 base 7. Then you can see now we can now drop the logs, and we will be left with x minus 2 x plus 3 is equal to 14. Then we can open the bracket. When we open the bracket, we get something like that one is x squared plus 3x minus 2x minus 6 is equal to 14. Then we are going to have x squared plus x, 3 minus 2x, 3x minus 2x, that one is x. Then we take 6 the other side, we have 20. This is a quadratic equation. We can now solve it using factorization method, and before we can do so, we should bring 20 on this outside, then we equate to 0. Minus 20 is equal to 0, so this is a quadratic equation itself. Then as you can see, we should be looking at two numbers. The product should give us negative 20, and the sum should give us positive 1, and the two numbers are positive 5 and negative 4. So the two numbers are positive 5 and negative 4. So x plus 5, x minus 4 is equal to, will give us 0. At this point, you can see the values of x will be, when this 5 crosses an equal sign, it will be negative 5. Or when 4 crosses the other side, it will be positive 4 of x. Let's do the last example, example 3. We have log 5x plus 7 is equal to 5. For this case, this to base 2. For this case, one of the sides we are given the log, but the other side we are not given. So it means we need to introduce a log. And as you know, when we want to write 5 in terms of log form, the first thing we need to do, we'll say log x to base 2, because we are using base 2 because we have been given base to be 2 here. Log x to base 2 is equal to 5. So when we write this one in indices form, it will be x is equal to 2 power 5, which x is equal to 32. Then we will come now that we have written that one in log form, we'll come now and drop the log, and we'll have 5x plus 7 is equal to 32. When 7 goes the other side, it will be 5x is equal to 25. 7 will be subtracted on the other side. Then we will be left with, we'll divide both sides by 5. X is equal to 5. And that is the answer. Okay, thank you for listening to this video. You can subscribe for more videos. Thank you so much.